All right, we might as well get started. Thanks for checking us out and catching up with this video. If you like what we're doing, please like and subscribe. Hit that bell notification for updates on anytime we drop a new video. We're going to continue on with our Breadboard to Market series, the stepper motor driver development kit that we've been working on. We're doing PCB layout. We're finally kind of nearing the end of all the design and development phase. So we left the ESP32 with 2 GPIO pins available. And I was thinking, let's just go and use them up. We're going to add additional functionality. Let's get rid of these do not connect flags. So the first thing we're going to add is an LED, another LED, like a status LED, kind of. Just be a red LED. I went ahead and grabbed one. Went ahead and grabbed an LED. So this could be like a status LED, an error LED, whatever you want to do with it. Let me go grab a copy of this resistor that we used on the 3.3 volt power supply. No reason to use anything different. Again, this will just be like a status LED, whatever you want to do with it when the dev kit comes out and you program it to whatever functionality you want. It could be a heartbeat LED, an error, a fault indicator. They'll just be here. We might as well just add the extra functionality. So we'll just throw that there. It's an LED driven by the ESP32 just for status. So then we want to throw another device on here. I'm going to want to throw we're going to throw a temp sensor. We're going to throw a temperature sensor in here. By the stepper driver chip. It'll be a little SOT. I've already decided on one, picked one out to help kind of control the fan. We'll write a so that's input. Yep. So we'll grab a copy of that, go over to the stepper driver. I'll throw this on here. Like I said, I went ahead and picked out a temperature sensor we've used before. It's calibrated, outputs degrees Celsius. No reason not to use it. It's real easy to use. It just puts out voltage that's calibrated for the temperature range. It's just a matter of getting the right values for it. So let's grab some of our filter caps. All right. Do we have a 22? No, let's go over here. We'll grab that guy. All right. So let's see if we can get this guy cleaned up a little bit. Just get the schematic thrown in here. 3.3. Capacitors pulled in here. Just the filter caps. Power supply. It's going to be an output from here. All right. Drop that in. Drop this guy in. Drop these guys together. And then this just gets pulled up to 3.3. That could shut down the temperature sensor if you don't really need it. You can just pull it down to load it to turn this temperature sensor off, but we don't need to do that. So we have the temperature sensor that we wanted to add. We have the status indicator that we wanted to add. We can use it to be a visual indicator of fault on the board. No big deal. So that's been thrown in there. I went ahead and added all the parts to Odo and all that, so I don't have to worry about that. I don't have to take time. Let's go and bring those new parts over. Update PCB from schematic. Update. Close. Going to bring in the new parts. Let's go ahead and get these guys. Ah. There we go. These are the parts that support the temperature sensor. Let's go ahead and kind of move these. We want that relatively close to the stepper chip. Kind of maybe put it there. And then this will be the status indicator LED and its current limiting resistor. All right, so we can probably drop these guys somewhere maybe around here. Be a little status indicator. So since we got a couple more little small components to plumb in, let's kind of get them figured out. Temperature sensor. Probably not too bad of a place for it. We don't want it right on top of it, but it will feel the ambient temperature in the PCB substrate and around it. Should be okay like that. We might put a little bit off to the side. Right there might be all right. Kind of go that route. 94. All right. So let's look at which one of these guys is the actual power line versus the signal to control the shutdown. Pin 4 is the shutdown. So the actual power line's over here. Right. 9, 2. $89, 50. We can probably go 50. That should be fine. All right. Get you guys plumbed in a little bit. That's just a data trace. Let's get this guy nice solid ground. So fills in. Aha. Let's go and fix that. All right. Now let's get the 3.3 tied in. Well, let's actually do the ground over here. Let's get these guys tied in. Ground. Right. Put you in. Right. Now I get the 3.3 volts tied in. Bring this guy up here. See what that looks like. Okay. Go. All right. So now we got the temperature sensor laid in. Let's get our status LED. Now we could probably throw it right around in here. Yeah, let's just do that. Let's put it here. 62, 40. All right. And what we'll do. We'll just give it the status. We'll just kind of just do this with it. There we go. Status LED, boom, that's tied in there. Let's go ahead and do some tracing. There we go. All right. Now it looks like we've got most of our components laid out where we want them. Now is going to come the extremely entertaining fun of routing. So good thing we have basically 4 signal layers we can route on: top, bottom, and then 2 internal layers. We've already designated internal layer 1 to be basically predominant north to south routes, and internal layer 3 to be predominantly east to west. It's sometimes hard to determine which is which. So there's no promises. It'll be spaghetti by the time we're all done with it. but I'm going to start trying to route as much as possible through the top and bottom layers where possible. It's going to be fun. So let's begin. Technically, I don't like pulling from a test point. I mean, we can because it's a pretty good pad. I mean, there's no real harm in it. Take every advantage you can. All right. Actually, what we might want to do then is the bottom. All right. All right. Let's see where this guy goes. All right. Now we have to avoid this guy, so mainly because of there we go. All right, so now let's come over from this guy. Okay. Okay. There we are. Now let's carry. There we go. And one more input. Hmm. can do is continue off this guy. And probably right here would be a good place to do it. Coming through the top. All right. Cool thing is that's all of our control inputs routed. Things are going to get saucier when we have to start jumping into the inner layers and popping things around to get a little round. Things are going to get rowdy. Let's just go with that. So let's go ahead, since we're over here, let's get these guys brought in, the UART pins. Might as well stick with the bottom where we can. It's up here. So I'm trying to avoid the pin 23 and 24 because they need a route up. I want to try to get around them. It's kind of coming from the other way then. Just kind of bring off. Too big. Don't need that large of a connection. I don't like that either. Let's see here. Your TX. Your RX. Can't really route the top because of this. But I'll tell you what we can do though. Let's change some pace here. What we will do, it's not the cleanest way of doing things, but brought that to the bottom. That is then what we'll do. All right. Let's pull you down here. That way we can come in here, pull you around. Ooh. When you're paying attention to that, we can kind of go up this way. All right. So that gets those two UART pins tied in together. Beautiful. Now comes a ton of fun. Okay, so we got the UART bridge chip tied in, which is good. Let's figure out what we can do with, pardon me, the rest of these. Let's see here, step enable. Step. Yeah, it's going to get interesting. Because now our bottom's already getting flooded, our top's already getting flooded. We're definitely going to have to pop into the other two signal layers and pop around a little bit more. So, let's just start playing around with stuff, see what we can do here. All right. Each one we get tied in will be one closer to the end goal. So what we're going to do is come in, PWM, come up. Can't really stay on the top layer. Can't really pop down to the bottom layer. So we're going to have to go to the next inner layer, which is inner 2, which is the predominant north to south layer. Missing all this stuff at the same time. All right, that's some big V's right there. And then up to the top layer. All right. All right, fantastic. Predominant north and south layer. You got to run that via. Oh, I don't want to do that. Do it. See ya, one of via. That was bad, I'm sorry. All right, up to the fantac. All right. Do is we can pop a via. All right. Well, each one of these completed is one more that's out of our way we don't have to worry about. Okay. Things are just getting really, really saucy now. All right. We'll stay on the bottom or the top where we can. No guarantees, but let's see what we got here on the bottom. So 45 RX. If we come across here, so we got to make it over to here. Already on the bottom. It's be nice if this guy was on our way. So what we're going to do, we're going to drag him out of the way. Kind of do some rerouting here. All right. Okay, so that rerouted all these guys. Fine by me. Because now what we can do is start bringing these guys in, snaking them on the bottom. There's RX. You know what? It's not going to hurt. We will figure out what we can do. We'll move traces around as we have to. All right, and then top layer, bam. Go ahead, fill in all those. All right. Okay. This has always been the most entertaining part of doing any of this. See, now the problem is now the direction and the TX lines are trapped unless we go all the way up around. So what we can do is we can put those in the inner layer 3. Which, like I said, are predominantly east to west. So what we're going to do is come up here off the direction. And we're going to go to layer 3. Kind of come down around. Sorry about that. Trying to catch myself and mute myself before I actually cough in your ears. I apologize. All right. And then top layer. Now we got to do the TX. All right. Okay. Piece by piece, little by little, we are making our connections and trying to avoid as many headaches as we can in the process. So a lot of these we're going to have to drop into vias, inner layers just to escape and get out. And then once we get into the open waters here, as it were, we can do bottom or top routing. It's just escaping past the ESP32 right now. We'll want to probably try to stay within one layer to top routing as much as possible because we don't want too many vias in there. We'll do what we have to, though. Do what we have to. And a lot of this is going to be signal lines going over to this fella, right? The stepper motor driver. And we've got a lot of spaghetti mess to get through here. All right. Well, let's just start routing what we've got. So, start over here. We can stay at top. The problem is if we pop down to that layer, what we can pop down to that layer, get up here into open waters, pop back to the top, and route the rest of the way. All right. All right. We are looking at a big mess. All right. So we've already got a via here off of this pin anyway for the enable. Let's see where that goes. Enable. Oh, that's gonna be that's gonna sting a little bit. Well, I would like to predominantly do the routing north to south, east to west. I don't think we're gonna be able to. So we're gonna just go and route off of this guy. Right. Go. Step reset. All right. Where are you going? You know, let's try working back from the. Oh. So it relabeled those from ground. So let's just go on, because I had to transfer over changes. Let's go ahead and put those on ground. I should really expose those in the symbol, so I won't have to keep doing this. There we go. All right. See, now I done messed myself up here. Continue off of this guy. There's actually a via that comes off. So we can do is, I don't like that. Let's get rid of that. So what we can do then is pop down in there, sneak around those vias, come to that via. All right. Another signal line routed. And the more of these we do, the easier it'll get. All right. Well, or the harder, depending. This is always the most entertaining part about PCB layout is the routing. It's a huge puzzle to solve. A huge headache waiting in the works. Just waiting to make you want to scream and rip your hair out. Basically what it is. Loads of fun. All right, so let's try to get the rest of these guys tied in here. Stepper fault. Oh, I hate that when you do that. Okay, stepper fault. Where do you end up? You're all the way down here. Oh, but I do have a via already underground, already going into the dirt. You know what? I can do that. I can hit here. Nothing from this side. Oh, you booger. Not what I wanted. No, there. All right. Oh, look at you. We can go through and yeah, let's kind of cozy those up. Clean those up a little bit. All right. Next guy. The direction. I mean, we're chunking through them. We really are, which is good. We're chunking through all the connections. We can go through and clean up anything if we need to. Like, I don't like, yeah, how that guy's like, let's pull that away. Let's see, separate direction, DIR. Where do you come at? You're here. Of course, there's going to be some complications here. These guys are tied in, so we can start routing up and drop vias in over here. Or come up and start dropping vias in here, but we also have these guys to drop in too, these vias. All right. Let's see if we can avoid a couple of vias. Or, so at the end of the day, this stuff needs to be... don't do that to me. Don't do those little dog legs to me. All right. If I go there, might be able to do a little bit of this kung fu. Let's go in here, pop up here. That one's do not connect. So if I pop in here, and then I come back out here, are you kidding me? What in the world are you doing? Stop. Oh, I need to come up here. There. That's what I'm trying to do. Jeez Louise. Ever closer we creep. Ever closer we creep. Now the temperature sensor, let's go ahead and see about getting it. Where you gotta go? You're up here. Well, you're gonna be fun. See, one of the things too, I want to really. Oh, yeah, look you there. I'm glad I kind of just poked my head over here. Go here. Let's go get this guy routed in. That's the feedback for the switching power supply. But one of the things you want to try to do, if you can, every chance you can, is avoid routing any signal traces under or too close to switching power supplies, mainly under, especially the switching circuit, which is your inductor, the boost capacitor, and everything. You just want to try to avoid routing around that. That's where all your high frequency noise is going to be. So just a word of advice and caution. So temp sense needs to go up there. I could start routing it around. Can it go around this way? Not really. I mean it can. I mean, I gotta bring that up, but if I bring this, okay. Okay, we're gonna go to layer number. Might be able to do that. Go to here. All right, and then we're going to I just don't like it being routed too close to. Should be more than enough. All right. All right, that's the temp sense. All right, we are plugging and chugging. Now the status LED. Oh, so close to being able to just stay on the top layer. So let's go ahead. All right, up here. I don't know if you'll be able to. All right, let's go. Oh, you little booger. Let's go. Oh. There we go. All right. Little status LED. Now it looks like we've only got 3 more signals to run up to the stepper motor. Wow. All right. All right. Okay. So. Okay. Well, we know we're going to have to drop into inner signal layers. So I'm just going to go ahead and kind of get some pre-routing done. Even though it's not tying to it. We're just popping into there. Okay. So we still have quite a few spots on this layer here. Let's just go ahead and use it. Oh. Oh. Well, let's go here. Let's see what we've got. Actually, that might work. And then we come to the top. And we just kind of route along. Okay. Perfect, perfect. Oh, watch that. Let's go here. Oh, we might actually get lucky because that looks like that's when the next one's up. And I don't know why you're acting like that to me, but okay. One more signal to route. And it's going to be the most stubborn one, the step direction. So we can do, so we can kind of come this way. See what we got in here. So let's go there. Yeah, because the problem is we need to get into here, in between these guys. Trying to see if there's an escape path. What about bottom? Top route it. Yeah, there's interference here. Top route it here. Get to the bottom. that might work. So let's see here. Let's do some serious kung fu. So if we kind of come up here. Wonder then if we get here. No, I can't get to the bottom, but oh, yes, but that layer will work. We can nail it here. All right. Holy cow. I think we're all finally routed here. Looks like we're all routed. Don't see any air wires. Re-pour all the planes to make sure nothing's tying together. See about doing a design rule check. Probably going to flag a bunch of stuff, but, you know, that's fine. I'm unfamiliar with this tool. Whole clearance. Yeah, we'll have to figure out all this. Yeah, we're going to have to fix some of this stuff. Oh, there's unconnected grounds here. Oh, yeah, clearances, mainly of pads, things too close together. Oh, what in the world is that all complaining about here? Yep. I never even noticed that, but good thing. All right. They're here, so did not even see these guys, so good thing we ran that. Round. What's kind of cool is can do then all right. So what to go through and clean up all our rules. Delete all markers. Run DRC. 300. Yeah. So what we're getting is violations here of the individual pads, the individual footprints. Now I know in Ultimate Designer you could tell it to ignore pads and footprints for these tests. So we're gonna have to see about adjusting the rules to allow for it. Adjusting all that. There's a lot we're gonna have to go. Clearance violations. Yeah, we can click all that. Default clearance 2030. Okay. And it's probably upset because we've got some courtyard clearance overlaps here, which I don't really care about. That's just courtyard. And since these are hand placed components, I'm not really going to be concerned about. And you know, if you look at the 3D view, they look they're close, but they're not like super overlapping each other. So I think that's fine. Yeah, it's just a matter of getting in here and cleaning up clearance rules, making things align, trying to go for 0 clearance violations. But the good thing is the main things I want to look for, I want to get these clearance. It looks like it's mad about like hole sizes, silk screen sizes. It's pointing out all our silk screens. I'm going to go through and clean up all. We'll do all that. Go through the violations in the next video. Clean up all that, try to get down to at least 0 rules, or if any violations are still shown, we'll see if they're acceptable and we'll just leave them. Or we'll just make adjustments to the rules so it doesn't matter. But yeah, it's mad. It's flagging like silk screen, it's flagging holes. So I've got some of the design constraints set up wrong, or some of the rules set up. We'll go through and we'll fix all that. But we'll do that in the next video. We'll kind of really start our design review in the next video, kind of double check everything, peruse everything, and hopefully begin the bomb creation and export the Gerber files for manufacturing. Hopefully we'll start that in the next video, but we'll see where we end up. I thank you for watching and checking us out. You have a good evening, and see you tomorrow.